Hello, in this video I'm going to go over Gauss's law in relation to magnetism. I just labeled this Gauss and magnetism. I'm just going to write down the first equation that you have, and this is the symbol for flux. In this case it's a magnetic flux, not electric flux, and that's equal to the integral of B dot dA. Both these are vectors. This will give you a scalar though. And you could also rewrite this BA cos theta, cosine theta. And this is area, the magnetism, and this theta is the difference between the two. So say we have this is some plane. The area is going to be, direction is going to be pointed out. And then we have magnetism pointing this way. Magnetic field line pointing this way. This theta will be right there, and that'll be right there. Essentially, what this is saying is that if you get this magnetic flux, it's kind of like the net magnetic lines going through a specific area. I kind of look at it like potential, though that's probably not correct. So there's this, say we have this this plane, this area, and we have the vector line, which is the normal line, coming out. If you've taken Calc 3, you understand why. If not, just know that the area vector is basically one of the faces on a plane. And then we have this magnetic field line, B. Now the theta here is going to be 90, obviously. So you have this 90 degrees. What's cosine 90? Anyone know? It will be 0. So the flux here will be 0. So that being said, there's no net flux. There's no potential on this. I don't want to say potential. I'm just going to say there's no magnetic flux on this plane. Now if we have a straight plane, we have dA and magnetic field line, we get cosine theta to be 1, because cosine 0 is 1. So we get the maximum amount of we get the maximum amount of flux based on the magnetic field in the area. Essentially what this means is that if we have a loop or like some arbitrary loop, or some arbitrary area, some arbitrary plane like this, we're going to get, if there's something in this plane, you're only going to get part of the magnetic field. Part of the magnetic field is going to affect you based on cosine theta. It's just like Gauss's law, if you remember that. It's really not too difficult. One last thing, Gauss's law through any closed surface. And any closed surface is B, A, or dot dA. This will equal 0, because you'll have just as many, if you have like a magnet, you're going to have just as many lines coming in as leaving. Which will then loop back in, actually. And this is not the same for Gauss's law when you're dealing with electric fields. Because electric fields, the internal electric field will project outwards. Whereas in magnetic fields, it'll all loop back inside. I hope this helps explain a little bit. If If you have any questions, feel free to comment. I'll make a new video if you feel it's required, explaining probably more specifics that I was asked. But thank you for your time, and I hope this helped.